What's going on, everybody? Mr. Enyart with Mr. Enyart's Mathematical Compositions. This is grade 6, module 5, lesson 10. Let's do it. All right, so lesson 10 from grade 6, module 5 of Eureka Math. We're finding perimeter and area of this rectangle. So there are two ways to find area of rectangles. One is to just add all the sides together. So 5 plus 9 plus 5 plus 9. And obviously, some previous skills we need to know is that opposite sides of a rectangle are the same, and that we have 4 right angles, 2 sets of parallel sides, and that's why that works out. But the other option is to do twice the length, so 2 9s, and plus twice the width and 2 5s. So these are really the same thing. This is just kind of a shorter version of plugging it in. So since we know the opposite of 9 is 9, then at least the sides, the opposite of 9 is negative 9, but the opposite side is also 9. We're going to have 18, and then we're going to be adding that to 10, because that's 2 5s for the 2 widths. And then obviously that would give us our perimeter, which is going to be 28, and it's going to be centimeters, since we're using centimeters as our units. Now area is just length times width, which would be 9 times 5, which gives us 45. And that's going to be centimeters squared, since it says an area, because we're literally making square units. So what if we have the area, but we're missing one of the sides of a rectangle? To find the area, we would still start with area equals length times width as our formula, because we know that this times this would give us the inside space, but we know the inside space. So now we plug our 1.2 in for our area, and that's 1.5 times W. And so we want to get W by itself and figure out what that's equal to. We need to get rid of this times 1.5. And how do you get rid of a times 1.5? You divide by 1.5. And so we're going to divide 1.2 also by 1.5 to keep our equation balanced. Remember, it's like a teeter-totter or a balance beam, and over here we have the 1.2, and over here we have the 1.5W. And so if we change one side by divided by 1.5, we have to also change this by the same, and that will keep it balanced. So on to the side, we can do 1.2 divided by 1.5. And since we don't like dividing by decimals, we're just going to multiply them both by 10, move the decimal over. So it's really 12 divided by 15, which obviously 15 can't go into 12. So we're going to have 0, and then we're going to have to add some point zeros here. And how many times can 15 go into 120? So 15 times 4 is 60 because of time, right? 15, 30, 45, 60. And 2 60s is 120, so 2 4s is 8. And that's going to be 120. So our width is 0.8 meters, or if we're using fractions, we could say that that's 4/5 meters. So this is a good opportunity for you to challenge yourself and find things around your house. Obviously, we're not at the school right now during quarantine, but you can find other things, maybe not a desktop, maybe a tabletop. Try and find rectangular objects to make it easy, or triangular objects, because we do know how to do that. And then get a tape measure or a ruler, yardstick, whatever you have in the house to measure things with, and write down what the object is, give the measurement if you're using feet or inches, centimeters, meters, whatever, and then try and be as precise as you can to the nearest half, it looks like. Or maybe, if it's a ruler, you can probably do quarters pretty easily. And then area prediction, like what would you think the area is, and then you actually solve it, and then you also find the perimeter. So go ahead and try and do that. So as always on the problem set, I encourage you to try this on your own first, pause the video, fill it all out, then press play and watch my explanation. So go ahead and pause it and try it all on your own first. So we're now looking at a square, and a square we know has equal sides, right? To be a square, you must have 4 right angles, 4 equal sides, and 2 sets of parallel sides. So this is a 1 by 1 foot. We're using feet as our units, which would make, once we come down, right, if we were to add these in here, this is going to be 2 by 2 from there to here, and then 3 by 3 to the next one, and 4 by 4 to the next. And so the question is, what does that look like down here. Now, this is pretty extensive, so I'm going to go ahead and just fill it all out and then go over really this one. Okay, so let's go through our areas here. So since we're expressing the area as side times side, right, length times width, but in a squares situation, let's get down here to n times n. How could you actually express this in a formula? Yeah, side squared, right? All this is 6 squared. This is 7 squared, right? So we could theoretically go back and rewrite all of those like this, right? And say that the formula for the area of a square, right? And it has to be a square. It can't be a rectangle, right? That has different length and different sides. We are looking at the area of a square. That would be side squared. Because we're literally, I know it looks like a 5, but that's an S. All right, and for perimeter, we just have 4 equal sides. So yeah, we could add them all up. Or for the perimeter of a square, we could say, and again, this only applies to a square, the special shape of a square that has 4 equal sides, that it's just going to be 4 times whatever the side is. I know, again, that looks like a 5. That is an S. That's an S. And so here down, you can see that if I'm doing the side, in this case 10, or in this case n, times 4, that's the same as just saying 4 times whatever the side is. So perimeter of a square is just 4 times the side, and the area is just the side squared. Now for B, C, and D, this is just, some observational questions. Which is greater, the area or the perimeter? Well, again, it depends. I mean, if you only have a 1 or a 2-inch or 2-foot or 2-unit long side, the perimeter is greater, right? 8's bigger than 4, and 4 is bigger than 1. But once we get down to, let's see here, so we get to 5 units for the length of a side, our area becomes greater than our perimeter. So it depends on the length of the side. Once we're at 5 or greater, on this table, there's decimals and other things we could look at, but on this table, 5 or greater means area is bigger, 4 or less means, 3 or less means perimeter is greater. And then here at 4, we get our answer to C. They're the same, right? 4 times 4 is 16, and again, if we're doing the length of 4, that's also 16. And so that would be helpful to see, in a square, imagine that's a perfect square. If this is 4 by 4, that's just 4 4s to, add up for the perimeter, which you could do 4 times 4. And then length times width, or side squared, is also 4 times 4. And so why is that true? Because, again, 4 sides times the length of 4 gives you 16, and then length times width, or side squared, which would be 4 times 4 is 16. So on this question, we need to find the perimeter of the pool and the perimeter of the walkway, which will be surrounded by these strips of non-stick stuff. And so we're just doing length, right? This is not area. This is just length in meters. And so you can see on my work over here that I first found the perimeter of the pool by using my formula of 2 times the width plus 2 times the length to give me 50 plus 50, and 15 plus 15, which is 130. The walkway was 90 plus 90, 2 90s, which is 180. And then we add the 25 plus the 25, which was 50, giving us 230. And then when we add the pool and the walkway, we get 360 meters that will need non-skid strips. Now, at 50 meters per, right, 50 and 50 is 100, we need to get to 360, all right? Well, that's going to be 7 gives you 350. That's not going to cover it. So we're going to need 8, and we will have, looks like we'll have 40 meters left over. Does that make sense? Because 8 will give us 400 meters. 8 times 50 is 400. And so we only need 360, so we'll have 40 meters left. For question 3, it seems really busy, but it's kind of a fun question. I'll zoom in down here and show you. I'm a big fan of drawing pictures to help you understand what's going on, but in a bedroom, you're going to have 4 walls and a ceiling, right? We know the walls are 18 feet, and then there's 2 walls that are going to be 18 feet, 2 that are going to be 12 feet, and they're all going to be 8 feet high, and then you're going to have your ceiling, which is 18 by 12. but you're going to subtract the 2 doors and the 3 windows. Now, he says he needs 4 gallons of paint at 300 square feet per gallon. That it'll cover, which is 1,200 square feet of paint, theoretically. So let's see if that's right. Apparently it's wrong, since it says show that his estimate is too high. So it's claiming that he's wrong. So here we go. All right, so here is a picture of the room. We have 18 by 12 by 8. So this wall and the opposite wall back here will be 18 by 8. That's what this is. 2 sets of 18 times 8, which is 288 square feet. Then you've got the 12 by 8 wall and its opposite. So there's 2 of those. And then you've got your ceiling, right? So your ceiling is going to be the 18 by 12. And so we add all that up and we get 696 square feet total. But then see the windows, I just kind of drew them in wherever. And the doors are being X'd out. So there's 2 sets of the doors, 3 by 7s. And there's 3 sets of the windows, 3 by 5s. So take time to make sense of this. That's 87. So when you subtract the doors and windows from the total, you only get 609 square feet of paint needed. Now, let's zoom in just a little bit more here. 1 gallon of paint is 300 square feet. So that means 2 gallons would be 600. So we'd still be just shy. But 3 gallons would cover 900 square feet, leaving us a whole lot of leftover for touch-ups later or for other fun projects. 4 gallons is 1,200 square feet. We don't need that much. So bada bing, bada boom, proving it. So here's what I drew for question 4. Started with 9 times 4, right, for the perimeter, because the perimeter is 36, so a square. And then I just started going up 1 for both of the opposite sides here, and down 1, and that continues to equal 36. So all of these are options, all the way down to the 16 foot by 1 foot. But the question asks which one yields the greatest area and the least area. So 9 times 9 is 81. That area there would be the greatest, right? Because that'd be 81 feet squared. All of these are in feet. And then 16 by 1 would only be 16 square feet, because 16 times 1 is 16. So this is our minimum area, and this would be our maximum area. So if they have space for a 9 by 9 square, that would be their best bet. And then it just kind of works backwards, right? This would be the next smallest, or next biggest, sorry. Then let's see, the 11, 77 is third. And then 12 and 6 is 72. That's fourth, so on and so forth. Question 5 is pretty simple. We've already done one like this, so we're just going to use our area equals 1.4 as our length times the width, and then we're going to get rid of the 1.4, and since it's being multiplied, we're dividing that from both sides. So 1.82 divided by 1.4, as you can see, I just multiplied them both by 10 to move the decimal over to divide by a whole number. I end up with 1.3, or 1 3/10 meters. All right, and the last question isn't that difficult. I prefer decimals over fractions, so I converted, halves, 0.5s, right? And then 3/4, 0.75, pretty easy. So I set up the area of 3.75, or 3 3/4, is the same as the 1.5 width times the whatever the total length is, right? So the total length, as I divided then by 1.5 to get length by itself, and divided 3.75 by 1.5, was 2.5, or 2.5 feet. So to do B, all you got to do is take that total 2.5 feet and subtract the 1.5 feet that is already there, and you will get left with X. So X is equal to 1 foot.
Well, that's the end of the video. I hope you enjoyed yourself. If you have any questions, please feel free to comment below or message me on Schoology. Have a wonderful day.